this is Mr. Knowles, and this lesson is about prime factorization. Prime factorization is finding which prime numbers multiply together to make the original number. And how we do this is with something called a factor tree. So I'm going to go over that with you. I'm going to use the number 24. Before we get started, though, we have to remember that the number 1 is not prime nor composite, so we do not use the number 1 in our factor trees. So write that real quick. Do not use the number 1 during this process in our factor trees. So I'm going to use the number 24. I'll make two little lines like that. We call them branches, and all you got to do is ask yourself, what times what is 24? How about 6 times 4? And then you look at those two numbers, and you ask yourself, are those numbers prime? Neither of them are prime, so we just repeat the process. We give each of these numbers two little branches, and you ask yourself again, what times what is 6? And remember, you can't use the number 1 in this process. 3 times 2 is 6, and 2 times 2 is 4. And you ask yourself, are any of those prime numbers? And in fact, all of them are prime. So I'm going to highlight them, so then I know I'm done. And I'm just going to write them in order. 2 times 2 times 2 times 3 equals 24. So I got 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24. And that's prime factorization. We have learned in class to use something called exponents. So what we could do is look at these 3 number 2's that are here. There's 1, there's 2, there's 3 2's. You could write this like this. 2 to the 3rd power times 3 is equal to 24. We just learned that in class, and it takes a little thought, but this little number 3 represents just what we did up above. You have 2 times 2 times 2. You have 3 2's multiplying each other. And some kids and adults will get confused and they'll think, well, 2 to the 3rd power means 2 times 3 is 6. That's not true. What that means is you have 2 times 2 is 4, and 4 times 2 is 8. So really 2 to the 3rd power is 8. Then times 3 is 24. It takes a little practice. If you can get to this point using exponents by the end of the school year, that's great. But for right now, if this makes more sense to you, by all means, do that, please. I'm going to do this one more time in a different way. So again, I'm going to take the number 24, and I'm going to use a factor tree to find all the prime factors, or the prime factorization of the number 24. How about 12 times 2? Well, the number 2 is prime, so that branch ends. Notice that there. 12's not prime, so I can keep working with the number 12. Let's see, how about 3 times 4? Well, 3 is prime, so that branch ends. I like to highlight them. You could circle them or underline them, but highlighting them kind of helps you visualize that those branches are done. 4 is not prime, though, and 4 is made up of 2 times 2. And if I highlight them all, I can see I got the same answer that I did on the previous page. So let me just write it down here real quick. I got 2 times 2 times 2 times 3 equals 24. If I go back my previous page, I got the same thing. I got 2 right here. 2 times 2 times 2 is 3. So no matter what way you build your factor tree of a particular number, you're going to arrive at the same answer if you do it right, which is great because there's lots of different ways to build factor trees for different numbers. I am going to do one more factor tree. I'm going to do the number 125, and that sounds like it's going to be a lot of work, but really it's not. I know 125 is made of 25s. I know it's made of 5 25s. And are either of those prime? Well, yeah, 5's prime. 25's not. So I can keep working with that one. Make my branches. 5 times 5 is 25. And the number 5 is prime. We just learned that. So my answer, 5 times 5 times 5 times 5 is 125. Or if I want to get fancy and use exponents, I have 1, 2, 3 5s. So 5 to the third power is equal to 125. I'll accept either of those answers, and I hope that this helps you out at home or wherever you happen to be watching this. Again, if you have any questions, feel free to ask.